Hello everyone, Model Maths Nagaraju YouTube channel. Matrices, properties of determinants. So in the previous part, 4 very important long questions are completed, and here also 5th and 6th are very important long question, and then after 4 marks question, then after 2 marks questions. In this video, mostly we can complete the properties of determinants problems. Within 2 videos we can complete. So it's a very important. Okay, with simply we can get the 7 marks and 4 marks. Okay, if determinant a square 1 plus a cube, b square 1 plus b cube, c square 1 plus c cube is equal to 0, and determinant a square 1, b square 1, c square 1 not equal to 0, then show that abc is equal to minus 1. This is the question. So we need to prove abc is equal to minus 1. Okay, so these two statements are given. So we are following this one. How to solve this? This is also very important problem. So please subscribe if you are newly watching, and also click the like button. Okay, now I am removing the question. This is a given statement and that we have to prove. So this is the given that determinant 1 a square 1 plus a cube, so answer is equal to 0. So in the third column, the each and every element of third column is sum of two terms. So we can split it into two determinants. So first elements as it is b square c square, a square b square c square. In the last column 1 and a cube b cube c cube, a cube b cube c cube. So keep it as it is because of the determinant is not 0, and here in the right side, from first row we can take a common, from second row take b common, from third row take c common. Then 1 a square, b common, 1 b square, 1 c square is equal to 0. And here it is same. So no need to change. A square 1, b square 1, c square 1. And here these two are same. Almostly looking like these two are equal. But the first row column is ABC, but here first column is 1. Okay, so what we can do, this second column write in first column, immediately first column write in second column, first column write in second column. So C1 C2 are interchanging here, C1 C2 are interchanging. Whenever C1 C2 are interchanging, this plus becomes minus, yeah. And also after changing this 1 goes to second column. Okay, first I am doing this a square 1, b square 1, c square 1 minus abc 1 a square b square c square is equal to 0. Now are both same now? Again small difference. The second column, third column are not suitable to second and third, just reverse are there. So to get same columns, again C3 write in C2, C2 write in C3. So in the next C2 and C3 are interchanged. C2, C3 are interchanged. So minus will come. So minus into minus, in the next step plus. Okay, plus. Minus into minus, in the next step we get plus. So determinant a square 1, b square 1, c square 1 plus abc into a square 1, b square 1, c square 1 is equal to 0. Am I right? The third column is written in the second column elements are written in the third column. So minus becomes plus. You can keep minus here or here, no problem. So but don't think, sir, you forgot here plus is there, you wrote minus. Next it is minus, you wrote plus. Why it is written as minus? Because of in the above step 2, now two columns are interchanged. So minus are changed. And again second, third are changed. So minus become plus. What is common in both? In both the determinant a square 1, b square 1, c square 1 is common. Here nothing, 1 is common. Here a plus c is remaining, is equal to 0. So already we know this is equal to 0 or this is equal to 0. But this is said that it is not 0. So it is not 0. So given that a square 1, b square 1, c square 1 is not equal to 0. This is given. So immediately 1 plus ABC must be 0. 1 plus ABC must be 0. That means plus 1 sent right side, ABC is equal minus 1. Got it answer? Hence proved. Simple problem. Just third column is written as sum of the two determinants and the second determinant is changes. We get the same first determinant. Take common. The remaining is 1 into A plus B plus 1 plus A plus BC, 1 plus ABC. Using 1 plus ABC is equal 0, we got the ABC equal minus 1 is the answer. Next, go to next problem. Yeah, sixth question. Show that determinant 1 A square A cube, 1 B square B cube, 1 C square C cube is equal A minus B into B minus C into C minus A into AB plus BC plus CA. So, taking LHS 1 A square A cube, 1 B square B cube, 1 C square C cube. So, I am trying to get these two becomes 0 by helping the R1. So, R2 I am going to change as R2 minus R1. Similarly, R3 also I am going to change as R3 minus R1. So, then first row I am not changing, but second row minus first row I am doing 1 minus 1 0, B square minus A square and B cube minus A cube, Similarly, third row minus first row 1 minus 1 0, C square minus A square and C cube minus A cube, Okay. So, here I am just rewriting 1 A square A cube 0. This B square minus A square I am rewriting as B minus A into B plus A. And this B cube minus A cube is written as, can anybody say, A cube minus B cube formula, A minus B into A square plus AB plus B square. Like that, B cube minus A cube is B minus A into B square plus AB plus A square. Similarly, 0, C square minus A square means C minus A into C plus A. And C cube minus A cube means C minus A into C square plus CA plus A square. Here we need to know what is A cube minus B cube formula. Yeah. From second row, what is common? Yeah, very good. B minus A. From third row, C minus A. So, first one, last one we are getting. Yeah. So, B minus A into C minus A taking common. 1 A square A cube 0 B plus A means I am writing A plus B. Here B minus A common, remaining A square plus AB plus B square. In orderly I have written. So, here 0, C minus A took common means C plus A is remaining. Here C square plus CA plus A square is remaining. Okay. And B minus C is required. So, do second row minus third row. B minus C. So, C minus B we get R3 minus R2. So, R3 becomes R3 minus R2. So, first these are B minus A, C minus A as it is. And what I am doing? First row, second row I am not disturbing. Those are 1 A square A cube. Second row 0 A plus B, A square plus AB plus B square. Third row minus second row 0 minus 0 0. C plus A minus B is C minus B. And C square plus CA plus A square minus A square. So, A square cancel. So, we get C square plus CA minus AB minus B square. So, tell me C square plus CA plus A square minus A square cancel, minus AB minus B square is remaining, minus AB minus B square. Okay. So, here we get B minus A into C minus A into determinant 1 A square A cube 0 A plus B A square plus AB plus B square 0 C minus B. Here I am rewriting this one as rough work I am doing. So, here, so C square, this is minus B square plus this is CA minus AB. From here and here C minus B is into C plus B, and this is C common remaining, A common remaining C minus B, and both terms C minus B is common. By taking C minus B common, we get to C plus B plus A means A plus B plus C. Okay. So, do the rough work. What is the expansion of this one? Now, C minus B common, first one automatic 0. So, take C minus B common, remaining B minus A into C minus A into c minus b, then 1 a square a cube, 0 a plus b, a square plus ab plus b square, 0 1 a plus b plus c. Then after nothing to do the transformations. So here it is a minus b, if you write minus common, here b minus, if you write minus common, minus into minus plus. So here we get clearly a minus b into b minus c into c minus a. We got the order. This to be get. So do this determinants. 1 into a plus b into a plus b plus c, a plus b plus c, minus 1 into a square plus ab plus b square. So simplify this, definitely we get this one. Okay, so continuation, a minus b into b minus c into c minus a into, see, a into a square, a into b ab, a into c ac, next b into a ba or ab, b into b b square, b into c bc, minus 1 into a square minus ab minus b square, which are cancelled, plus a square minus a square cancel, plus ab minus ab cancel, plus b square minus b square cancel. What is the remaining? ab bc ca, sum. So which is equal a minus b into b minus c into c minus a. So ab plus bc plus ca. Got it? Answer is equal RHS, hence proved. So this is the clear explanation. So these 6 are very most important for long questions. If you learn these 6 questions, okay, 99% you can get 7 marks from this chapter. Okay, the second 7 marks question is easily we can get. For first 7 marks question we have 4 methods: Cramer's rule, inverse method, Gauss-Jordan, consistent, inconsistent. Okay, yeah. Next, go to next 7th problem, 7th, 8th or 4 marks question. Sometimes they may ask 4 marks for 7 marks, 7 marks for 4 marks, but so that is a very rare case. Yeah. The same type of problem in the previous question and question, just a small difference, a square a cube instead of a square, b square, c square, and this only. So very easily you can directly I am taking this is LHS. Okay, so we have to prove this RHS. So these two are going to be transformed as zeros. So R2 becomes R2 minus R1 and R3 becomes R3 minus R1. So then first row I am not changing, second row is changing, 1 minus 1 0, b minus a and b square minus a square, and third row 1 minus 1 0, c minus a and c square minus a square. So from second column b minus a is common, am I right? And third column c minus a is common, then 1 a square, 0 1. If you take b minus a common, remaining is b plus a, 0 1. If you take c minus a common, c plus a is remaining. Then R2 or R3. Okay, however, R3 becomes, I am doing R3 minus R2. So then 1 a square as it is, 0 1 b plus a as it is, 0 minus 0 0, 1 minus 1 0, c plus a minus b plus a. So plus a minus a cancel, c minus b is remaining. So from third row c minus b is common. Here b minus a into c minus a. Third row c minus b common. So we get b minus a, c minus a, c minus b into determine 1 a square, 0 1 b plus a or a plus b, 0 0 1. So we get 1. If you, because of this upper triangular matrix, 1 into 1 into 1 1, otherwise do it. So this is a minus b, I am writing as b minus a writing as a minus b. So minus common, or minus into minus, minus c plus b. So b minus c and c minus a, and this is 1. So is equal to RHS, hence proved. Okay, very simple question, the same process like as the previous question. Next question. Yeah, next 8th question, show that b plus c, c plus a plus b, plus b, b plus c, c plus a b c is equal to a cube plus b cube plus c cube minus 3abc. I have taken LHS and now would like to minimize the terms. See, in the second row elements and in the third row elements I am observing. In the second row elements, two elements are there. In the third row, single elements are there. So second row minus third row if you do, if you do second row minus third row and write in second row, so what you will get, a plus b minus a becomes b, b plus c minus b becomes b cancel c. Yeah, so b plus c plus a plus b, and a plus b minus a is b, b plus c minus b means c plus a minus c means a, remaining a, b, c. Now see the first row and second row. So first row b plus c, second row b. If you remove b because of by subtracting second row, ఏం లేదండి, ఫస్ట్ రోలో డబుల్ ఎలిమెంట్స్ ఉన్నాయి, సెకండ్ రోలో సింగిల్స్ అండి, సేమ్ పైన ఏం చేసినా కింద అదే చేయండి. సో ఫస్ట్ రో బికమ్స్ ఫస్ట్ రో మైనస్ సెకండ్ రో. సో b plus c minus b is c plus a minus a is a plus b minus a is b, and b c a b c. Now find the determinant, you will get the answer. Okay, however I am doing, if you understood, you just pause the video, find determinant. So for c into c square minus ba, c square minus ba means ab, c square minus ab. Next a into minus a into a square minus bc, a square minus bc plus b into b square minus ac, b square minus ac. So c into c square, c cube minus abc minus a cube plus abc plus b cube minus abc. So a cube plus b cube plus c cube minus 3abc is the answer. Yeah, it's called RHS, hence proved. So a simple question. Next, sorry here just small change, bc minus a square, this is, so minus a into bc minus abc, and minus a into minus a square plus a cube. Okay, first write this one and this one. Better to do the step by step. Write one more step, c into determinant minus a into determinant plus b into determinant. Because of 4 marks question, simple question, you write the step by step. So this question sometimes asked for 2 marks also, sometimes 7 marks. This is find x, the determinant so and so is equal 0. So this is the given. By simplifying, we need to find x value. So this is given, that not LHS, completely given, not proving. So this is given. So second row elements x minus 4, first row elements x minus 2. If you do x minus 4 minus x minus 2, x cancel, some number we will get. So R2 becomes R2 minus R1 and R3 becomes R3 minus R1. So first row we are not changing, x minus 2, 2x minus 3, 3x minus 4. So second row minus first row, x minus 4 minus x minus 2, x 4 minus 4 minus x minus 2, x cancel, minus 4 plus 2 becomes minus 2. So we get minus 2. Similarly 2x minus 9 minus 2x minus 3. So 2x cancel, minus 9 plus 3 is minus 6. And here minus 16 plus 4 is minus 12. And third row minus first row. So minus 6 we get. Minus 27 plus 3 is minus 24. Minus 64 plus 4 means minus 60. Is anything common in the second row and third row? Because of is equal to 0 is there. So yes, take minus 2 common and send outside. Take minus 6 common, send outside. So we get x minus 2, 2x minus 3, 3x minus 4. Here minus 2 take common. We get 1, 3, 2, 6 ja. Here minus 6 common, 6 1 ja, 6 4 ja, 6 10 ja is equal to 0. Again you can convert this one to 0 by R3 minus R2. Otherwise find the determinant from here onwards, directly you will get the answer. Minus 2 into minus 6 is plus 12. Plus 12 if you send right side becomes 0. Okay, so R3 becomes, I am doing R3 minus R2. So then x minus 2, 2x minus 3, 3x minus 4. Second row we are not changing, 1, 3, 6. Third 1 minus 1, 0. 4 minus 3, 1. 10 minus 6, 4 is equal 0. So I didn't write to minus 2 into minus 6 plus 12 because of 12 send right side goes to 0. 12 into 0. Now find the determinant, x minus 2 into determinant 3614 minus 2x minus 3 into determinant 1604 plus 3x minus 4 into 1301. 3x minus 4 into 1301 is equal to 0. Am I right? Okay. Now x minus 2 into, now 3 4 is 12 minus 6, 6 minus 2x minus 3 into 1 4 is 4 minus 0, 4 plus 3x minus 4 into 1 1 is 1 minus 3, 1 equals 0. So now simplify, you get the x value. 6 into x, 6x minus 12 minus 2x into 8 minus 8x plus 12 plus 3x minus 4. How many x terms here? 6, here 3, 9 minus 8 x, and constant terms only minus 4 is there. So center right side x is equal to 4 is the answer. Okay, sometimes this is actually 2 marks, but one time they asked for 7 marks. Asked for 7 marks question. So last 2 more questions are there, we will write. The next question, show that y plus z x x y z plus x y y z z x plus y equal 4x y z. So there is no properties of determinant used. Directly find the determinant, you will get the answer 4x y z. How to find? LHS, y plus z into z plus x y z x plus y minus x into plus x into. Okay, I am finding LHS. I have taken LHS. Okay, we should prove 4x y z. So x into y y z x plus y, x into y z plus x z z. So y plus z into z plus x into x plus y. What do you get? Z into x, zx plus yz plus x square plus xy minus yz minus x into y into x, xy plus y square minus zy or yz plus x into y into z, yz minus z into z, z square minus zx. Okay, is here yz minus yz cancel, so nothing cancel. Now simplify, so nothing, y into zx, xyz, y into x square y, y into xy, xy square, okay, y into x. Next with z into zx, z square x, z into x square z, z into xy, xyz. Now minus x into xy, minus x square y, minus x into y square, minus into minus plus xyz, plus xyz minus xz square minus zx square. See, xyz, 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 4 xyz terms are there, the remaining all are cancelled. X plus x square y minus x square y, yeah, plus xy square minus xy square, yeah, plus xz square minus xz square. What are the remaining? Yeah, plus x square z minus x square z cancel. Got it answer? So simple question. Because of what I am saying in this method, sometimes if you don't know about this question, you may think about which property is suitable. Here no property is used, just find the determinant and get the answer. Okay, next question. The next one is very important for 2 marks. Okay, have you written? Okay, so next question is, so that is very important and 2 marks question, that's for 2 marks question. Omega is a complex cube root of unity, then show that. Question is, omega is a complex root of complex cube root of unity, then show that. Okay, determinant 1 omega square, omega square 1, omega square 1 omega is equal to 0. Yeah, so here what do you mean by complex cube root of unity? Cube root of unity means 1 power 1 by 3, x is equal 1 power 1 by 3. So for this condition we have 2 statements. One is 1 plus omega square equal 0, second one is omega cube equal 0. And particularly about this concept you will know in intermediate second year first chapter complex numbers. complex numbers, first chapter, Maths 2A. In that chapter, you will have several problems. Not only there, and quadratic expressions also, fourth chapter in Maths 2A only. So, at this time, you just remember these two statements. Whenever omega anything is complex cube root of unity, then two conditions, omega cube equal to 1. These two conditions are possible. So, now taking LHS, I have to prove is equal to 0. So, very simple. Here we clearly know 1 plus omega square equal to 0. So, by adding first row, second row, third row, first column, third column, we get 2. Or otherwise adding R1, R2, R3. So, R1 becomes R1 plus R2 plus R3. So, R1 plus R2 plus R3. 1 plus omega square. Here also omega plus omega square plus 1. Here also omega square plus 1 plus omega. And next write as it is omega square 1, omega square 1 omega. In the first row, 1 plus omega square means, so first before this better to write, given that omega is complex cube root of unity, that implies 1 plus omega square equal to 0 and omega cube equal to 0. 1. You must write these two conditions first for this question. First write this statement, then after take LHS, then do this one, then write. Okay. So, here we can write 0, 0, 0, then remaining 1 omega square 1, omega square 1 omega. What about this answer? 0, because of if one of the row of element, one row is 0, then the determinant is 0 property is equal to RHS, hence proof. That's it. Okay. So, these are the complete properties of determinant chapter. One question for 2 marks that is given in the model paper. Okay, is it complete first? Yeah. So, next I would like to tell you one question. Actually, that is not important, but that is a like a theoretical problem, but very easy that one. It is in example also in your textbook. A certain bookshop has 10 dozen chemistry books, 10 dozen chemistry books, 8 dozen physics books, 8 dozen physics books, 10 dozen economic books, 10 dozen economic books. Their selling prices are rupees 80, 60, 40 respectively. Selling prices are 80, 60, 40 respectively. Using matrix algebra, find the total value of the books in the shop. Okay. Using algebra, find total value of the books. So, actually generally 10 dozen means 10 to the 120 books, 120 into 80, some 1960. In that way we can solve in algebra, but he is asking algebra. So, question is completely just simply given information I have written, given that. But question is, once again I am writing, a certain bookshop has 10 dozen chemistry books, 8 dozen physics books, 10 dozen economics books, and the selling prices of each one rupees 80 rupees, 60 rupees, 40 respectively. Find the total value of the books in the shop. This is the question. Okay. Using matrix algebra. So, books. So, this is the given information. So, 10 dozen means each dozen carries, 8 dozen means 12 books. So, 10 to the 12. So, books are, let the matrix 10 dozen chemistry books. 10 dozen chemistry books means 10 into 12. 120 books. Next 8 dozen physics books, that means 8 into 12, 96 books. Next 10 dozen economics books means 10 into 12, that is 120 books. So, prices are 80, 60, 40. In the matrix formation I have written. So, books are books are formation 120, 96, 120. Okay, the books are written in row matrix, prices are written in column matrix. Sir, why? What happen if you write books are in the column matrix, prices are row matrix? So here the total amount is a single amount that should be in the matrix formation, whatever the amount, that is one by one element, one by one matrix formation. మొత్తం కూడా 1/1 లోకి రావాలి అంటే 1/3 into 3/1 చేస్తే 1/1 మ్యాట్రిక్స్ వస్తుంది. అదర్వైజ్ యూ టేక్ ద బుక్స్ ఆర్ ఇన్ కాలమ్ మ్యాట్రిక్స్, ప్రైజెస్ ఆర్ ఇన్ రో మ్యాట్రిక్స్. ఓకే, ప్రైజెస్ ఇంటూ కాలమ్ యూ డూ, దట్స్ ఇట్. సో టోటల్ ప్రైస్ is equal 120, 96, 120 into 80, 60, 40. Okay, actually properties of determinants is completed. So one question is left, I didn't say whenever, so just I am remembering this problem. 120, 1 into 3 and 3/1, 3 cancel, 1/1, 120 into 8, 12 8 are 9600 plus 96 into 10, 60, 6 is 36, 6 9 is 54, 57, 120 into 40, 4800. You find the total, you get the answer, that is 20,160 is the answer. Okay friends, completely this chapter matrix consists how many parts? 14 parts. How many questions from this chapter? 2 7 marks question, 2 4 marks question, sorry, 2 2 marks question, 14, 4 18, 1 4 marks question, 1 4 marks question. Okay, totally 22 marks. Very easily we can get with using these important questions if you learn. So enough, this is enough. You are intermediate first year. Many times I told you, in the inter, no need to learn each and every problem from the exercise. If you just learn the important question, easily you can get the good score. Okay, 75 marks easily we can get if you watch all our videos. Maths 1A, Maths 1B, second year 2A, 2B also is there. Any video if you want, just search Matrices part 1 by Nagaraju sir, Matrices part 2 by Nagaraju sir, functions part 1 by Nagaraju sir, additional vector part 1 by Nagaraju sir, additional vectors part 2 by Nagaraju sir. In this way you can get or see the playlist, you have the, you can know the, you can get the videos. Thank you watching, thank you very much. Please subscribe and share with your friends. Thank you.